Okay, we're going to be looking at rise over run on this part regarding slope. So, when you have, well, let's first understand what rise over run even means. And once again, that's a fraction. And this is just a way of thinking about slope. So I have these examples below. Slope equals rise over run. When you have a slope of 2 and a y-intercept, that's what that b is. That means y-intercept, and that comes from the equation y equals mx plus b, which I have or will have several videos on that equation. B is the y-intercept. What we're just looking at right now is how these concepts correlate to the graph. And then we will look at ways to calculate rise over run. So B refers to the y-intercept. What that means is that is where a point on the graph crosses the y-axis, or is sitting on the y-axis. The point itself sits on the y-axis if it is the y-intercept. So for this b equal 2, that means on the y-axis, this axis here, b is 2. The y-intercept, the point is 2. So that means if it's a point, it has to have an x and a y. The x, because we have not moved any direction along this axis, is 0. And we went 0 and then up 2. So the point itself is 0, 2. That's the y-intercept. Y-intercept is b. So we're given the slope. So this is where we're going to start. If we have a point on the line, because this is telling us this is a point on the line, and it's specifically a special point, it's the point that is on the y-axis for that line. We don't know any other points. We're only given a slope. But what we know about this slope too is that it's rise over run. So 2 over, remember you can put all whole numbers over 1. That means it's a 2 rise over a 1 run. So we begin at this point on the line, and we're going to start to build the rest of the line just using the concept of rise over run. So rise is the up and down direction. Because it's a positive 2, we go up 2 spots, 1, 2. If it were negative 2, we would have had to start here and go down 2 spots. So we begin on this point, and we go up 2, and the run is 1, and it's a positive 1. So on the run is this direction, the x direction. And because it's positive, we go to the right. If it were negative, we would have had to go to the left. So we begin on the point, the y-intercept, we go up 2, positive 2, we go over to the right 1 because it's a positive 1. That's rise over run, and that tells us where the next point is. We draw the point. When we can keep doing this, up 2 over 1, up 2 over 1. Now, remember, if you have a negative 2 over a negative 1, that is the same thing as positive 2 over positive 1, because a negative divided by a negative is a positive. So we can go the opposite direction, exactly the opposite. That is, we could go down 2 to the left 1, and that's the same slope, but we're just following it along in the opposite direction. So down 2 to the left 1. And notice this is not making our line go off. It's still a line. It's a linear equation, so it is going to make a line. All right, so then let's attach those points. And we were able to draw a line based just on given a slope and one point of the line. This point of the line is particularly the y-intercept point. We could be given other points on the line. All of these examples use the y-intercept simply because that was the fastest one to calculate. So for me in these examples. So now let's look at this next example over here where the slope is 1/2 and the y-intercept is -3. So what we have is we begin on a point, and we're going to begin on a very special point, the y-intercept, which is the point of the line that crosses the y-axis. Let's go back to our red pen. I think my graph is falling out of this picture, but I think it'll be all right. So we're going to start here, go down 3, because remember our y-intercept is a point. The x is always 0, and we're going to go down 3, because that's the nature of the y-intercept. It's along the y-axis, so you could not have gone any direction on the x line if you're on the y-intercept. So x is 0, and then y is -3. 1, 2, 3. So there's our first point that we can identify of our line. We're going to use the slope of 1/2 to find the other points on the line. So we have rise over run. So let's put it up here. Rise, 1. Run is 2. So we go, this is a +1. We go up 1, and we go to the right 2 for the run. So we start on this point. We go up 1 over 2. And there's another point. We go up 1, +1, to the right, +2. Up 1 over 2. And look at that. We got a point now on the x-axis. That is an x-intercept. Okay, we go up 1 over 2. And again, you can do the opposite direction simply by making both numbers the opposite. We begin on that point again. We go -1 down 2. Oops. Did I do the wrong thing? No. -1 over -2. 1, 2. Sorry. Down 1 over -2. Okay, so then we have another line. So this is basically showing you the concept behind rise over run. What does it do? How does it help us to understand linear equations? How does it help us build a line? So of course in this last example, we'll go through this one a little more quickly. We have a y-intercept, this point where it crosses the y-axis, which is going to be 0, 4. So we go x0, we go +4, 1, 2, 3, 4, and there's a point on our new line. We're going to use our rise over the run, which is -3 over 2. So we start on our point, we go down 3, 1, 2, 3. We go to the right, +2, 1, 2. There's a point. Down 3, 1, 2, 3. To the right, +2, 1, 2. Down 3, 1, 2, 3, over +2. Okay, let's go. We can change it to the opposite, make it a +3. Oops. make it a positive 3 over a negative 2. Start at that point again. Up 3, 1, 2, 3, over negative 2, 1, 2. Up 3, 1, 2, 3, over negative 2. So now we have several points of yet another line. And where is our color? Black. And we can connect those dots and have a new line. So that's how RiseOverRun works.